So today I'm going to go over 1-15 cosecant, secant, cotangent graphs. So this first part I'm going to do a little faster. We did them in class. You could ask me how I got different values, but once you get the hang of it, I hope you understand what I'm doing. So first I'm going to fill out the sign values. Okay, so sign is just using the circle. We're going to go to the y value. So I'm just going to show the circle here, but I'm going to be looking at it. So the sine of 0 is 0. Sine of pi over 6 is 1/2. Sine of pi over 4 is square root of 2 over 2. Sine of pi over 3 is square root of 3 over 2. Pi over 2 is 1. 2 pi over 3 is square root of 3 over 2. 3 pi over 4 is square root of 2 over 2. 5 pi over 6 is 1/2. Oops, I'm sorry. Oops. Oh, maybe I could do it like that and show both. Okay. Pi is 0. 7 pi over 6 is negative 1/2. 5 pi over 4 is negative square root of 2 over 2. 4 pi over 3 is negative square root of 3 over 2. 3 pi over 2 is negative 1. 5 pi over 3 is square root of 3 over 2. 7 pi over 4 is 11 pi over 6. And I'm just going to write it in so it is there. 2 pi, it is back at 0. Okay? Now, for cosecant, that is 1 over sine. Let me try to get this to show the whole thing. So we're going to take the reciprocal, okay? So this is 0 over 1, right? Because if I have 3, oh, now you can't see it. If I have 3, that's like 3 over 1. So this is like 0 over 1. So when we take the reciprocal, we're going to do 1 divided by 0. And I cannot divide anything into 0 parts because it doesn't exist. So this is undefined. So this one is also undefined. Okay, take the reciprocal of this, we get 2. Take the reciprocal of this, we get negative 2. Take the reciprocal of this, we get 2 over the square root of 2. Now, if we don't like the square root in the denominator, this is 2 square root of 2 over 2, because those cancel the radical, which is just square root of 2. So for this, because we're going to be graphing it, I'm going to use this value, 1.4. So the reciprocal of this is 1.4. Square root of 3 over 2 is 2 over the square root of 3, which is 1.1. Reciprocal of this, 1 over 1 is 1. 2 square root of 3 is 1.1. 2 square root of 2 is 1.4. This is 2. Now we're going to do the same with the negatives. So reciprocal of this is negative 1.4. The reciprocal of this is negative 1.1. Reciprocal of this is negative 1. Negative 1.1. Negative 1.4. Negative 2. And this again is undefined. Okay, so now we're going to use these values to create a graph. And unfortunately, it's on the other side. But I have the values up here. Okay, so I think your graph may be on the same page, but mine's on a different page. So for cosecant, I'm going to write it up here, which is 1 over sine, is at 0, it is undefined. So that means we have an asymptote. It means a line that it doesn't cross. It's undefined. At pi, we have another one. At 2 pi, we have another one. And you could guess it happens every pi. Okay. At pi over 4, our value for cosecant was 1.4. Pi over 2, it is 1. 3 pi over 4, it is 1.4. So over here it is 2, and over here it is also 2, so it goes up like this. At 3 pi over 2, it is -1. 5 pi over 4, it is -1.4. 7 pi over 4, it is -1.4. Between there, it is -2. Between here, it is -2, so it goes down like this. Then you could guess this one. Is that 1? 1.4, 1.4, 2, 2. Sorry for that noise. And then over here it is -1, 1.4, 1.4, 2, 2. Okay, so this is the cosecant graph. I'm going to get another pen and remind you what sine looks like. Let's do bright red. Okay, so sine, remember sine I always say is king. So sine goes through 0, 1, 0, -1, 0. This is one cycle, one period of sine. Whoops. So you could tell, and then it does it again right there and right there. So you could tell this one is sine of x. When normally it's above the axis, that's when you have this. When it's below the axis, that's when you have this. So that's the graph of cosecant. These questions, I'm not going to be able to show the graph and the questions, maybe. Oh, I can. So, for what values between 0 and 2 pi does cosecant equal 1? Well, let's look at the blue. Pi over 2 and 5 pi over 2. What values does equal -1? 3 pi over 2 and 7 pi over 2. Now you're not going to be able to see the graph. What values does it have a vertical asymptote? From 0, so this includes 0 and 2 pi. So at 0, pi, 2 pi. And all values, where does it equal 1? Well, the first one starts here, and then it happens 2 pi later, and then 2 pi later, and also back the other way. So the first one is at 0, and then you could do plus 0 plus or minus pi. Another way you could write that is saying 0 plus or minus, you could say c pi or k pi, where k is a constant whole number. And it could be positive or negative, which is, I just went blank, an integer. So I could have 0 plus 2 pi or 0 minus 8 pi or whatever. You could write it as either one. So that is cosecant. Oh, here's another question of cosecant. I think it's on the same page for you, so now I can show the graph. What values, I'm sorry, I know when you're watching a video it's even smaller. Does it equal -1? 3 pi over 2, and then we're going to add 2 pi. Okay? So 3 pi over 2 plus or minus k, I'll say 2 pi. Because this is pi and there's another 2 pi. You could have k 2 pi if you wanted to be a constant. And then where do we have vertical asymptotes? We have them at 0 and plus or minus pi. Or you could say 0 plus or minus k pi, because there happens every pi is the asymptote. Okay, so that's cosecant. Cosecant is 1 over sine. So now let's go to secant. Secant is 1 over cosine. Let me show you the circle. I can't really see it. Okay, so let's do the cosine values, which are the x values all the way around. I'm trying to look at my copies to make sure I have, no, that's cotangent. There's cosecant, so secant. So we're going to do cosine. So cosine are the x values. So we're going to start at 1. Pi over 6 is square root of 3 over 2. Pi over 4 is square root of 2 over 2. 1/2, 0, negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, negative 1, negative square root of 3 over 2, negative square root of 2 over 2, negative 1/2, 0, 1/2, square root of 2 over 2, square root of 3 over 2, and just so we have it, 2 pi, it's back at 1. Okay, so now let's take the reciprocals. That one's easy, that one's easy, that one's easy. This one, the reciprocal is dividing by 0, so it's undefined. Undefined. That one's easy, that one's easy. Oop, 5 pi over 3. Did I do it right? 5 pi over 3. Yep, positive. Okay, now let's do these. So we flip this, we're going to get this, which is 1.1. So wherever I have that, this is negative 1.1, negative 1.1, 1.1. And then we flip this, we're going to get this that I did 1.4, negative 1.4, negative 1.4, positive 1.4. Okay, let's graph it. So this one is secant, which is 1 over cosine of x. So at 0, we are at 1. Remember, cosine starts at 1, so does secant. At pi over 2, it is undefined. I guess I'll do my asymptotes first. At 3 pi over 2, it is undefined. So again, that happens every pi. 1, 2, 3, 4. 1, 2, 3, 4. So this graph goes all the way to 4 pi, even though 2 pi is one cycle. So it starts here at that pi over 4, it's at 1.4. So this one starts going up like that. Pi, it's at negative 1. 3 pi over 4, yep, negative 1.4. 5 pi over 4, negative 1.4. Between that, it's at negative 2, negative 2. So it doesn't cross that dashed line. Here you could guess, here, 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 positive 2, positive 2. Here is negative 1, negative 1.4, negative 1.4, negative 2, negative 2 between there. And here it is positive 1, 1.4, positive 2. Just going to do half of it there. The other half goes up like that. This other half goes up like that. Okay, so there is secant. So let's do cosine on the same graph so you can see the difference. It's going to be the red. So remember, cosine starts at 1, and then at 2 pi, it ends at 1 again. So between there, it is down here. This one is right here. This one is right here. So it goes like that. I'm only going to do one cycle of that so you can see. So when it is 1, that's when it's going up. When it is negative 1, that's when it's going down. The blue have the asymptotes, but cosine doesn't have any asymptotes. It continues all the way through. So having your graph out, Let's go for the back side. There's 6 questions about secant, which is this graph we just did, which is 1 over cosine. So from 0 to 2 pi, where does it equal 1? You can look at the table of the graphs. It's at 0. I don't know why I switched to red. 0, 2 pi, and that's it. Only 2 places it's positive 1. Where does it equal negative 1? Only at pi, and that's it between those two. What values does it have an asymptote? Vertical asymptote is pi over 2. This is just going to 2 pi, 3 pi over 2. That's it. Where does it equal 1? From all of it, it equals 1 at 0, and 0 plus or minus 2 pi. Or you could say 0 plus or minus k 2 pi, where k is any integer, positive or negative. And then where does it equal negative 1? At pi, and pi plus or minus 2 pi, or you could say pi plus or minus k 2 pi. Where does it have asymptotes for all of them? Pi over 2 plus or minus pi. Okay, so that is secant. Now let's do cotangent. I think cotangent's a little easier in that you could either think of it as 1 over tangent, or you could think of it as x over y. You could just flip it. Now, when you're dividing it, I've been seeing this error. Let's say we're doing the tangent of pi over 3. I'm going to write it here because I'm going to do a shortcut. So that is your y divided by your x. Well, when you divide these, you take the reciprocal of the bottom, so this times reciprocal. And what happens to your denominator? So the same thing, so they cancel. So you're left with this value over this value, y numerator over x numerator. So that makes tangent a little easier, I think. Let me go back out. So tangent at 0, it is 0 over 1. Remember, tangent's y over x, and cotangent, we're going to do the reciprocal or take x over y. So this is 0, so this is undefined. At pi, again, it is 0, so this is undefined. Pi over 6, it's 1 over square root of 3. That is 1.7. Pi over 4, when we divide the same number, we get 1. Pi over 3 is the square root of 3, which is 0.6. Pi over 2 is 1 over 0, which is undefined, but then it is 0 over 1, which is that. This is negative square root of 3, which is negative 0.6. I'm taking the reciprocal and putting that. 3 pi over 4 is negative 1, negative 1. 5 pi over 6 is negative 1 over square root of 3, which is negative 1.7. 7 pi over 6 is 1 over square root of 3, which is 1.7. 5 pi over 4, which is 1. 4 pi over 3 is over 1, which is 0.6. The reciprocal, I'm doing it all in one step. This is undefined. So this is 0. This is negative, which is negative 0.6. This is negative 1, which is negative 1. This is negative 1 over, which is negative 1.7. Okay. So if you remember, tangent already has some asymptotes, and so does cotangent. So here we are going to put cotangent in blue. So the cotangent is at 0, undefined. And at pi, oops, then you could guess also at 2 pi. We didn't write it here, but at 2 pi, this is 0, so this is undefined. Then, at pi over 4, it is 1. At negative pi over 4, it is also 1. At pi over 2, it is 0. At 3 pi over 4, it is negative 1. In between there, it is negative 1.7. I don't know, I guess I'll go in between there. And over here, it's positive 1.7. Anyhow, it looks like that. And this one starts going like that. Okay, then this one, 3 pi over 2, it's at 0. 5 pi over 4, it's at 1. 7 pi over 4, it's at negative 1. Again, it's like right here and about right here before 2. So, cotangent looks like this. If you don't remember, tangent at 0, it's at 0. At pi over 4, it's at 1, and I think I did this wrong in class. At pi over 2, it's undefined. At 3 pi over 2, it's undefined. Goes like this, though. So at pi, it's at 0. Oops, that's not a good curve, but it goes down. I didn't go through the points, just so you see it. So the red is tangent, and the blue is cotangent. So they cross over each other. I think in class I didn't show them that way. I used the same asymptotes. So I'm glad I'm doing this in video that you could see the difference now. They have different asymptotes, and tangent is increasing, so less here, reading left to right, and cotangent is decreasing. Left to right starts up and then it goes down. Oh, the pages are printed wrong. That's what's going on. Okay, so the last ones, let's talk about cotangent. 0 to 2 pi, where are the x-intercepts? They are at pi over 2 and at 3 pi over 2. Vertical asymptotes are at 0, pi, 2 pi. So this is just for 0 to 2 pi. This talks about forever. So x-intercepts, if we have it at pi over 2, plus or minus k pi. They happen every pi. So half a pi to 3.5 pi. 3 halves is 1 pi. We add 2 over 2. And then vertical asymptotes, we start on 0 plus or minus k pi. Those happen every pi also. And you can see it here. So asymptotes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This section is 12 for pi. So asymptotes are every pi. Now the x-intercepts right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That adds pi for the x-intercepts also. So those two. And that is it. Let me know if you have any questions. Thanks.